What if we could send a message to the past? A warning, a whisper, a signal. What if the future had already tried to contact us, and we just didn't recognize it? Welcome to one of the most radical possibilities in physics, tachyon communication. In theory, tachyons are particles that travel faster than light, and by extension, could travel backward in time. This creates a tantalizing idea. Use them to send information into the past. But the implications are staggering. Let's unpack how it might work and why it terrifies physicists. In special relativity, if a signal travels faster than light, then under some reference frames it can arrive before it was sent. That means you could send a tachyon-based message from point A to point B. And at point B, the message arrives before it was ever transmitted. A closed causal loop is formed. If such loops can exist, they raise all kinds of time travel paradoxes, especially when it comes to information. Let's imagine a simple experiment. A scientist discovers the method to generate a tachyon pulse. She programs the system to send a signal if a specific result occurs in her lab. But what happens if she receives the signal before she even starts the experiment? Would that affect how she proceeds? Would she change the result? This is the heart of the information paradox. Where did the information originally come from? Who is the sender, and who is the receiver? It creates what scientists call a causal paradox, where the cause and effect are so intertwined that it's unclear which came first. In logic, this is unacceptable. In physics, even worse. But not everyone rules it out. In fact, in the 1970s and 1980s, serious physicists including E.C.G. Sudarshan and Gerald Feinberg considered theoretical frameworks in which tachyons could transmit information. To preserve consistency, some of them proposed rules such as tachyon signals must be random or non-interfering. Only closed loops are allowed if they don't result in contradictions. A fixed frame of reference might prevent paradoxes. Another approach is the Novikov self-consistency principle, which suggests that any action taken to change the past was always part of history, meaning the paradox is resolved because the loop is self-contained. You received the message because you were always going to. It's fate, but dressed in equations. In science fiction, tachyon communication is often used as a plot device for reverse time broadcasting. Warnings from the future. Interstellar messages beating the speed of light. Quantum computers pinging their earlier states. One famous example is the movie Déjà Vu, where an experimental surveillance system based on tachyon physics allows law enforcement to observe the past and eventually try to change it. But could this ever be real? Let's explore some obstacles. Energy requirements. The generation of a controlled tachyon pulse would likely require exotic energy configurations, perhaps at Planck scale energies far beyond current technology. Detection issues. Tachyons wouldn't behave like photons or particles we can measure. They might only interact through gravity or higher dimensional fields. Signal stability. Because tachyons gain speed by losing energy, transmitting a consistent, structured message could be impossible. Cosmic censorship. The universe might inherently prevent such paradoxes from occurring. Like quantum uncertainty, it may bury contradictions beneath randomness. Even so, some physicists believe that quantum entanglement could one day be tied to tachyon-like interactions. Imagine this: two entangled particles separated by light years. A tachyon interaction tweaks one and retrocausally affects the state of the other, not by sending a readable message, but by changing the probabilities of outcomes. It's not classical communication, but it's influence, and that's enough to change how we think about information and time. Interestingly, there are also proposals in quantum cryptography to test for hypothetical faster-than-light correlations. Though no conclusive evidence has ever been found, These experiments push the boundaries of what's testable. Some even wonder whether tachyons could be used in interdimensional communication. If other brains or timelines exist, could tachyon flows cross them? This blends with theories of multiverse physics, where different regions of the universe operate under different physical laws. Maybe tachyons drift freely between them, acting as bridges between realities. It's wild speculation, but based on real math. Still, there's one central truth we keep returning to. Information defines reality. If tachyons can manipulate information across time, they challenge our most sacred principle, causality. And maybe that's the point. Maybe the universe isn't a straight line. Maybe it's a network of timelines, where information flows both forward and backward, and the tachyon is the thread connecting them. Until we find hard evidence, tachyon communication remains forbidden science. But like all taboos, it speaks to something deep, human, and universal. The desire to speak across time, to reach backward and change, or reach forward and hope.